because I don't know what kind of root I'm taking. Oh boy. No, you didn't. It was my pre-calc class.
I like just putting down.
So today we are doing nth roots.
And roots.
I know you're all so excited.
Only to say
What does
it.
the key-
I'm taking the root that is the nth root, like second has ND,
Oh, that's not a plus one.
third has RD. No.
Oh my
God.
I just saw that movie. Did you not see that? The horse is alive.
She's traumatized by that horse.
It won't be here Monday when you show up. It will be gone. It's okay.
Are they taking all that stuff down in the hallway?
Yeah. It was only
Yeah,
for
I
this
hit my
week.
head on every time I walk past through.
Imagine being that tall.
Duck your head.
Why would I duck my head? Why don't they just put it up higher?
I will say that the sophomore hallway looked awesome. And I did really, really like it. And I did vote for that as
Wait,
my
we have a
top hallway.
hallway?
Thank you.
Don't tell my freshmen.
Wait,
Wait,
we
where's the hallway?
The English hallway. So by Miss Amores' room.
No.
Yeah, so this is the freshman hallway. That's the English hallway. Seniors are down by Mr. Senior Kabajik's old room. And then downstairs outside of Miss Dollahan's room is the junior hallway. Yes. Okay, so when we're talking about roots, I'm going to show you some different roots and what it means if I were to write it as an exponential form instead of a radical form and how they correlate to each other. So the first one that we're going to be looking at is a cube. So a cube root, for example, is not cube root, sorry. A cube is when I take some number and I multiply it by itself 3 times. So if I have the example that x cubed is equal to 64, how would we figure out what number is my x here? Well, I would take the cube root of 64, and that would give me my root x. Do we know this off the top of our heads?
Not really.
So what we could do if we don't know what value this is we could take that number to the 1 over whatever exponent or whatever root I'm looking for here. So I was looking for the cube root here, which is the 3rd root. So I take it to the 1 over 3 power. And then this will tell me that the cube root of 64 is 4. Same thing applies if I'm taking, I don't know, trying to take the 4th root of something. So if I have x to the 4th equals 625, and my goal is to solve for x, what am I going to do? Well, I'm going to rewrite it as the 4th root of 625, which that then becomes, oh my gosh, 625 to the 1 over 4 power, which I can put into a calculator. Any ideas about what it's going to be?
25?
Not 25.
4.
5. And we can do this for any exponent that we're looking for. So for example, if I gave you x to the 5th is equal to 32, I want you to solve for x. Some of you might already know it. So get a calculator. You're definitely going to need a calculator today.
I just used the force.
The force. I'm not throwing a calculator, otherwise I would totally grab it and lob it at you.
I'm sorry, Caroline.
I just picked my desk.
Maybe.
I'm
sorry.
No, you're not.
You can file a complaint.
I will. Because you just picked my desk. And that's bullying.
I'm going to crock at you. Don't just.
I don't know, those big ones, they're complicated.
They're not that complicated.
Where are they?
Is this green?
I got like 100 and then I got 6.4.
Yeah, what's up, honey?
How do I type that with the 4 in it in my calculator, or do I have to do the 1/4? Because I'm not really.
You would do
Sam.
the 1/4. That's the whole reason we changed it into this, so that can be put into the calculator.
I think if you put like a number and then second that arrow, and then
So
No,
Oh, that's why. You have to put the 1 over 3 in parentheses.
Oh.
Okay, so if you're plugging this into a calculator, you need to be very careful about the parentheses that we use. So if I were putting this in, after I changed it into the 5th root of 32, I would put this in as 32 in parentheses, and then our upward arrow caret, and then parentheses 1 divided by 5. That's how you plug it into your calculator. Because if you just did the upward caret and then 1 divided by 5, it's going to take 31 to the first power and then divide your answer by 5, which is not what we want.
yeah, there's an easier way.
Of course, there's always an easier way, but we're not going there right now.
But there's an easier way.
But it doesn't work on every calculator.
I can't. I don't.
Yeah.
Not
I
what
didn't
means.
do parentheses.
Different I don't know, we'd have to look.
I didn't do parentheses in my
Some calculators are smarter than other calculators. So I show the dumbest way possible so that it works every single time.
Mine. Okay, that's a problem. It's not the calculator. Use it.
It could be that too.
I like that.
I don't know how to do. Oh, that.
Were we all able to get 32 to the 1/5 power is equal to 2? So we should have gotten 2 as an answer here. There are different ways of doing it depending on the calculator that you have. I'm showing you the way that's going to work for every single calculator. So you might have found a different way that works for yours. Awesome. Your calculator might not need as many parentheses. Awesome. Some do. So I show the dumbest way possible for the dumbest calculator out there. This will work every single time. Okay? Everyone okay with that? So then what if I present you with, oh, I don't know. Let's say the 11th root of some number x. If I knew what x was, could I plug it into my calculator? Yes, we would take whatever x is, and then we do the upward caret, and we do 1 divided by 11. So that tells me if I'm taking some number x to the nth power, to inversely take the nth root of that power, it would be the nth root of x. So this changes into this in order to solve it. Or actually it'd be the other way. It'd be like a to the n equals. There we go. That's more what I want. So if I took some number a to the nth power equals x, then taking the nth root of x would give me my base a. This is the correlation between an exponential and a root. We are not limited to just taking square roots. If there's no number in front of my radical, what root do I assume I'm taking?
1. 0.
So if I just gave you this, what root do you automatically assume I'm taking? The square root. If there's no number there, we assume it's the square root. If there is a number there, we assume it's a different root. Okay, so make sure you're paying attention to that. There's no such thing as a one root or a singular root. It doesn't work. There are different types of answers that we could get, though, for a root, specifically for a square root. So, for example, when I take the square root of 64, what's my answer? Positive and negative 8. Okay, we know this because 8 times 8 equals 64, but so does negative 8 times negative 8. So to avoid the confusion of which answer I'm actually looking for, they came up with a notation. So if I just say I want the square root of n, that means I want only the positive root. If I say I want the negative square root of n, this means I want only the negative root. And if I have a plus or minus in front of my square root, that means I want both, the positive and the negative. By doing this, I ensure I'm not doing any extra work I don't need to, or identifying roots that it's not looking for. So if we see nothing in front of a square root or an even root, so 4th root or 6th root, 8th root, I'm looking only for the positive answers. If I see a negative out front, I'm looking only for the negative answers. And if I see a plus and a minus out front, I'm looking for both. Which means my answer is going to have a plus and a minus on it. Does that kind of make sense? This only applies when I'm taking a positive root. Or not a positive, an even root. Oh my gosh, I can't speak today.
Are you going to go with the negative one too?
Yeah. So this only applies when taking an even root. So if I'm taking a square root, this applies. If I'm taking a 4th root, this applies. If I'm taking a 6th root, or an 8th root, or so on. So anytime I'm taking an even root, I need to pay attention to this.
Oh, so we just ignore that when we're taking a...
Like if we're taking a 7th root or a 5th root, we ignore it. We don't care. And then everything from here on out is just examples, applying it. So I do have a lot of examples on here. We don't necessarily need to do all of them. I'm going to kind of leave it up to you. As we move through this, if you get really, really comfortable, I'll pick and choose which ones we do. If you aren't really comfortable, we'll continue to do more. Okay? Does everybody have these rules written down? Okay, so let's start with an example. You feel like you're where? Oh my gosh, that's disgusting.
What?
First example, I would like to simplify the square root of 16y to the 4th. Oh. We're going to start off a little easier, just so you know.
What?
This
This is easy?
Just write it down.
I don't know if why.
I'm going to show you what to do with the variables that are in there. Okay, so don't worry about that.
That doesn't look anything like the root.
Those are rules that we're going to follow to solve these. There's a big difference. Okay, so the first thing we're going to do is identify what root I'm taking. So what root am I taking here? The square root, which is the 2nd root, okay? Which means everything inside, I need to rewrite with an exponent 2. This will allow me to easily take my square root. So when I rewrite this, I know that I can rewrite 16 as 4 squared. Right? I'm showing you how the root thing works. So I took 16 and I rewrote it as a number to the 2nd power. This ensures that when I take the square root of it, the square root and that 2nd power will cancel each other out. I do the same thing with my y to the 4th. What times 2 equals 4? 2. So that y to the 4th right here becomes y squared squared. And then this allows me to take the square root of both of those at the same time. So when I take the square root of both of those, these exponent 2's on the outside cancel because the square root of something squared is just that number, leaving just the base underneath. So my answer here becomes 4y squared. But it's positive and negative because I had a plus and a minus outside of my radical. Does that kind of make sense?
I'm confused. Why did you square everything inside of it?
Because I was taking the square root. So I needed my root and my radical to match. So I need my exponent and my radical to match. That's ensuring that it'll cancel it out. Then it doesn't cancel, then I have an issue. Let's just do some more and then we'll see if that alleviates your question. Okay? So let's do example B, which is I want the negative answer of the square root of x squared minus 6 to the 8th power. If it helps, I can write the number of the root I'm taking and kind of put it out front. So what root am I taking here? The square root, which means that in theory it would have a 2 out front because that's how we write all of our other roots. So what I need now is I need this root value to match with an exponent value on the inside so that it cancels out. So I need to take 8 and I need to think, okay, what times 2 equals 8? 4. So I need to break this up into this parentheses to the 4th power all squared. So this becomes the negative square root of x squared minus 6 to the 4th power to the 2nd power, because 4 times 2 equals 8. This then shows me that this square root and this square cancel, leaving just the negative of that parentheses to the 4th power.
Why wouldn't it cancel out the x squared?
Because the x squared isn't alone. So it wasn't what was on the outside of my parentheses. It only cancels from the outside in. Because I was taking that whole parentheses and taking it to the 8th power originally. So if it was just an x squared on the inside, it would have. But it wasn't just an x squared, it was that whole thing. So I can't separate that term out. Yes, Xavier. Oh, you're good. Okay. Is anybody kind of seeing what's happening? Some of you maybe? Let's try a different rooted problem. Well, we would, but we don't care right now. I'm really just looking at the radical part of this. But yes, you could, because that's a difference of squares, and I could just keep going from there. Yeah, absolutely. Example C. Let's say now I'm taking the 5th root of 243. Oh, I should really rewrite that 3.
Math is so much fun.
A to the 20th, B to the 25th. See, somebody's catching on. That's good. Not that I'm concerned at all for those of you who aren't. This is different. I know that. So which is why I put a lot of examples in here. So the first thing I need to take note of is what?
That's 5, 5.
That is a 5th root, right? So somehow I need to break everything inside of this radical down to an exponent of 5 on the outside. So the first thing I focus on is my number. I need to see if 243 has a whole number 5th root. So I can use my calculator by taking 243 to the 1/5 power and seeing if it comes out to a whole number. Hopefully it does. It should, yeah. What does it come out to? 3. So that means I can rewrite 243 as 3 to the 5th power. And then I move on to my next term. So I have A to the 20th. I somehow need to get that 20 in terms of 5. So what times 5 equals 20? Say it louder. 4. So A to the 20th becomes A to the 4th to the 5th power, because 4 times 5 equals 20. And then I will do the same thing with my B to the 25th power. What times 5 equals 25? 5. So this becomes B to the 5th to the 5th. Did everybody see how I did that? So now the super cool thing is that this 5 root right here cancels out every outside 5 exponent on the inside. Then what's left is my answer. So this equals 3, A to the 4th, B to the 5th. Do you have a question, Cadence?
Yeah.
Okay.
Like, do we have to write it out like that?
No, if you can see it, no. I, in my notes, like to do much more elongated problems or solutions.
It wasn't like part of the problem, like have to do it.
No, not at all. You find your own way that works for you. Some of you will see different shortcuts that other people don't see. Take them. That's fine. But I will always write it out like this in the notes so that anybody who doesn't see that shortcut will see what's happening. Show of hands, is this starting to make any more sense to any of you, how we break it down? Okay, I'm seeing a few less puzzled faces, which is awesome. So let's go ahead and do another one. And if it's not, that's okay. We will continue to work on it. So now for example D, I have the square root of negative 16 x to the 4th y to the 8th.
Okay, I understand the question. Wouldn't there be a plus or minus up front?
Not necessarily. If there isn't one, we automatically assume we just want the positive answer. Remember, that was one of our rules. Hold on. That was a great question. Absolutely. Okay, is this one going to work the exact same as the other ones? Why not, Madison? Okay, so I need to keep in mind that if I'm taking an even root, I can't have a negative number on the inside. I can if I'm taking an odd root, because a negative times itself 3 times can equal a negative, but not for an even root. This is a square root, which means it's a 2 root. 2 is even, which means I have no number times itself that's going to equal negative 16. So this is not going to happen. You cannot solve this answer. So you can just put no, or you can put no because there are no real roots. Or you can say no because the square root of negative 16 is imaginary. Okay, so we can't take the square root or the 4th root or the 6th root of a negative number.
Oh, that's cool.
That you can't do it? Or
Yeah.
I'm glad.
That's like the best news I heard so far.
Right? Don't even have to do any work.
I know. I'm hoping all these questions have a negative. I maybe I should go put a negative in every single one.
No, don't do that. That's not going to work well in your favor.
Did you make this? Right one. And we put a negative.
Is there one where we have to create our own homework?
Good thing.
Oh, so I have to put a
No,
negative.
I wouldn't do that.
That would have worked if it had. Okay, example E.
I'd make the hardest one and then put like a negative.
I get a mile long to put one
Just to
there.
be a mean.
I would like the positive and negative square root of 36x to the 10th. I would like for you to try this one on your own. Done already, Brandon?
I think so, probably.
Awesome.
Maybe
Talk me
not.
through it.
Oh, I don't want to do that.
Do it anyway.
I did the square root of 36. Got 6.
So I rewrote 36 as 6 squared, right?
Yeah.
Okay, and then what?
I rewrote x with x to the 5th in parentheses with a squared out.
Okay, so he recognized that 5 times 2 equals 10. So he rewrote x to the 10th as x to the 5th squared. And then what?
We canceled out the 2 squares. And there it is, 6x to the.
You had positive negative
I definitely did.
6x to the 5th though, right?
No.
You're supposed to say yes, because I can't see your paper, so I'm not going to know.
It's 2. I can't do that.
Okay, so we had
Two
plus
numbers.
and minus because I had a plus and a minus on the beginning of that original problem. Yes, ma'am.
Why did you cancel out the 2s?
Because it was a square root.
Oh, okay.
And so the square root cancels out the squares on each of my terms. Only 1 square per term though, if that makes any sense. Okay, how are we feeling about this? Who had this answer? That's not bad.
I got it after you're right.
Okay, well, that's not good, but that's okay.
I had to write my
see
middle
it.
note because I forgot.
You see it though?
I wrote down the install after.
Okay, let's go ahead and do another one.
Fucking negative side.
What do you have to give us?
So on this one, I had the negative square root of y plus 7 all to the 16th power. Connor, talk me through this one. The y plus of 7 or the 16? We just leave it as y plus 7 in parentheses. Okay. How did you know I was looking for something times 2 to equal 16, Connor? Perfect. We assume this is a square root because there was no number there, which means I was looking for something times 2 to equal 16. Perfect. And then what can we do from here, Connor? In the square root, right? And then we are left with the negative of y plus 7 to the 8th.
I wrote it differently.
How'd you write
I
it?
said x equals negative y minus 7. 8 with 8.
You can't do that because I can't distribute that negative 1 in until after I've taken it to the exponent. So PEMDAS, you have to keep that in mind. I am perfectly fine if you don't reduce this any farther. Like, this is how I want it. Okay? Yes.
How? Why did you move the 8? Oh, just I thought it was on the inside of the parentheses with the 7.
No. It was on the outside of the first set. Okay, how do we feel about that one? Is this starting to make sense? Good, because I'm about to throw a wrench in it.
Oh.
That was just universal.
Think algebra based. On based.
Isn't algebra like not counting anymore?
Algebra 1? Or not really. Not at the middle school anyway.
That G looks really cool.
I don't have to take it out.
Like it looks like the G is connected.
It does kind of. I kind of like that.
I really wish I could just.
I'm not going to make it a lot harder. I'm just adding one little thing. I promise.
Can you just cancel it?
Yeah.
Okay, hold on.
No. Don't ruin that.
Definitely does.
You should be able to cancel out.
Pretty sure.
First question. What root am I taking here? The fourth. Am I taking the positive fourth root, the negative fourth root, or both? Positive, because there's nothing out front, which means that I'm only taking the positive version. Awesome. Which means I need whatever exponent I have on the inside to be in terms of 4. Is it already there?
Yeah.
Yes. So logically, what do we see happening here? They cancel out, which leaves me just with y.
So what's the problem?
Hold on. What if that y was a negative 1, but I wanted a positive root for this radical? I can't ensure that the number I plug in is going to be positive. So math actually has this really cool thing that takes anything inside of it and turns it positive. What is it? The absolute value sign. When I need to ensure that my variable is the positive root, I have to use absolute value signs.
I mean, I'm not wrong.
Well, positive of negative 1 is still negative 1.
Not if you put 2 plus signs.
We only do
Say that again. We only do that when there's a variable I have to ensure is positive. So the key here, and I'm afraid this is going to confuse you more, is when I'm taking an even root, but I'm left with an odd exponent. So when I'm taking an even root, so here I was taking a fourth root, which is even, but I was left with an exponent of 1, which is odd. So the key here is an even root left with an odd exponent has to have an absolute value sign around it. That's the key. This does not apply to every problem. and we're going to do plenty of examples where I use it. And it only goes around the variables. If you have more than one variable, I prefer that you use more than one absolute value sign, but you don't necessarily have to. Okay? So let's do another one. That's the only wrench I had to throw in. That's the only one.
It's a pretty big wrench.
That was just a nail, just a temporary issue.
More like
So did I.
I was prepared.
Am I still on yours?
I don't know.
Okay, example H. I would like to take the 6th root of 64 times the quantity x squared minus 3 to the 18th power. So I need to rewrite everything in there in terms of what root?
6.
The 6. I need a 6 exponent on everything in there. So we need to see if 64 has a 6th root and what it is. Okay, so I heard that it's 2. Everybody should plug it in to check. If it's 2, then I can rewrite 64 as 2 to the 6th. Right?
Okay.
What if it doesn't and it like comes out?
All of the ones I gave you will. Okay, I promise. All the numbers I gave you will.
Is there something you can do?
Sorry,
You can separate one of them out, or you can separate a number out to make it perfect, but we're not there yet. Okay, hold on. Everybody focus. So we're all okay with how 64 turned into 2 to the 6th, correct? So now what about that parentheses x squared minus 3 to the 18th power? How can I rewrite that?
You put another set of parentheses.
Okay, what times 6 equals 18? 3. So I'm going to rewrite this as x squared minus 3 cubed to the 6th power. And then
You cancel the 6.
my stuff cancels. My root cancels out each of my 6 exponents, leaving me with 2, and then x squared minus 3 to the 3rd power. Am I finished?
No, you have to multiply the 2 and don't you?
So
Absolute.
Okay, say it. Yeah, you.
Absolute value.
I had an even root, and I was left with an odd exponent. I need to ensure that this number or answer will come out to be positive. This, because it's in parentheses, is all one term, so it all goes under my absolute value sign. The 2 doesn't because 2 is already a number and it's already positive.
Okay, the 3 is not in the parentheses. So why is that?
No, it's in parentheses. It's all grouped. The 3 is the exponent on it. It has to be in there as well. Yeah, that whole term has to be in there.
I'm looking at a room. I only got room for one.
So I had to use that because I had an even root left with an odd exponent. 6 was even, 3 was odd. Okay, that's why I had to use that. Are we kind of okay with that?
Yeah.
That is seriously like the hardest part here.
I think we only need one more.
You just put absolute values because I just needed to be positive. That was my only requirement.
What if there was no exponent?
Yes, because like if it was just this, yes. Yes. Okay, so
So why don't I put everything?
because this is already positive, so I don't have to do that one. And these only because it's a variable, that's why. Because I don't know what number I'm plugging into it. We have like 18 minutes left. We're gonna keep going. I do anticipate that we're gonna spend some time doing this on Monday as well. You should definitely still work on the homework. Don't wait till Monday because it will still be due on Monday. I just might give you in-class time to work on it too. Next one. I would like for you to do this one on your own. Thank you.
That's the last one I did.
Oh no, we got more. I went all the way to R in the notes.
No, you went to O.
No, I went to R. Oh, I think I added some extra ones that we're gonna write down.
I can't remember the alphabet.
I added those because I put those on the homework. So yes, we will also have 3 additional.
I lost count.
I can do the alphabet backwards.
I can't.
Is it bad that it was the alphabet?
I can like say it backwards.
It's hard. Whatever somebody says, like the alphabetical order, I'll like have to go through it.
Elemental
I get stuck at like Q.
Q R.
Oh, like you just can't go.
Yeah, like I can't think.
No, I'm talking about like you're doing something.
Okay, there's like 20 of them.
There are 26 letters in the alphabet.
Yeah.
It's pretty close.
Right.
Oh my goodness, who am I gonna call on?
Okay, 1, 2, 3,
But
4,
you know
5,
what
6,
you're
7,
doing.
Elijah.
Okay, it's too long.
Talk me through this one.
So I
Shh.
square root of 6 squared, and then in parentheses y to the third to the power of 2.
Okay.
And then I cancel the square root into both the squares. And then I put the absolute value around the y.
Perfect.
You left too much room. It was very obvious there had to be
I
something
know.
there.
So it should be 6 times the absolute value of y cubed. I was taking a square root, which is even, and I was left with a y cubed, which is odd. So make sure you're keeping that in your brain somewhere. Yes.
It might be a football.
But 6, the number, is unchanging. It's a constant. The only reason we do the variable is because I don't know what number is going to be plugged in the future. So I have to ensure no matter what that my answer ends up being positive. But yes, 6 to the power of 1 is technically odd. Technically. Okay. Who got this answer?
Without.
With the absolute value.
I put the absolute value.
Did you put it around the 6?
I think
Let's do another one.
A, B, C, D,
I know the alphabet.
H,
I
I,
know.
J, K, L, M, N, O, Q, R, S.
I would like for you to do this one on your own as well.
Oh my God, this is ready.
I was gonna say.
Excuse me.
After this one, I am going to skip to the last 3 examples that I have on my notes. That way we get them written down because they directly apply to problems that are on your homework. And then I will be done.
I did it.
You did it. Good. Bolt, are you done? Okay, I'm going to call on you in a minute. Okay, Bolt, talk me through it.
Well, you make the square root.
Is it a square root or is it a...
Well, the 4.
So we draw the radical. That's what we're going to call it now that we're not just using a square root. We're going to call it a radical.
But 2 in parentheses, to square root of 4. Or to
There you go.
and then parentheses, x minus 3. And then to the 3rd power, and then to the 4th.
Perfect. How does that reduce?
And then you cross out all the letters at the top. And then you have 2 parentheses x minus 3 cubed, and then absolute value on the parentheses x minus 3.
Perfect. So 2 times the absolute value of the quantity x minus 3 cubed. Show of hands who got that answer. With the absolute value sign in it. Jimena, honey, where'd we go wrong?
I was messed up with parentheses x minus 3.
Okay, so what are we messing up on, do you think? Or talk me through your process.
I keep forgetting about like the 12th power and the 4th. like I.
Oh, okay. So like splitting this one up into 4 times something.
Yeah.
Okay. So that's like really, really important.
Yeah.
So if we just practice that, but I think once you get that down, you'll be fine.
Yeah.
So just constantly remind yourself of that. So it also helps sometimes that I will underline each of the terms separately, I guess. So I remember I work with each of them, and it makes me really stop and think about what I'm supposed to be doing. So try that too. Okay. So I'm actually going to go ahead and skip to example Q. It is not written on your notes because I added it afterwards, but it's going to be in your notes in a second, which is perfect.
Wait, are we only doing 2 more?
Or
Yes.
TUV?
We only doing R.
I still have half a page.
I started like
The alphabet is like
I used to get mad at my mom for making me go to preschool because I already know, but now I wish I could go back.
Now you wish you could go back. I know I do algebra too right before I do my calc class. And so they walk in and they're like, can we just do this today?
Duran.
I know what I did.
Oh.
I know what I did.
What is that?
I know what I did. Just write it.
Nope, not possible. Can't do it.
Just
don't
write
like
it. It is 100% possible.
I don't like it.
Not like that.
what it is that there's
So,
something not
that is
right.
I think you're that is not.
Hang on to that, Patty.
Oh.
No.
Okay.
I didn't say that. That wasn't me. That was Brandon.
Are we all ready? I'm not going to make her do the problem. I'm just going to ask one little part. Okay. What do we see that we automatically don't like? 8 is not a multiple of 5. So I can't do what I've been doing. I can't break that up into an exponent times an exponent, which means I'm going to have to think about this differently. So I actually need to think about this in terms of if I break a group of 5 out of here, what's left? 3. So this can actually become the 5th root of 32 x to the 5th x cubed. Everybody see what I did there? So I took 8, I subtracted 5 from it, and then what was left I rewrote with that same variable in that exponent. I still have to break down that 32 if possible. Can I break that down into something to the 5th power? Do it on your calculators. Find out, is there a 5th root to 32? Shane already did it. So this becomes the 5th root of 2 to the 5th, x to the 5th, x cubed. It works the same way as we did before. My 5 radical out here can only cancel the 5 exponents underneath. Anything that's left remains under the radical.
I got 2.036 now.
You definitely.
Is that
Okay, I'm gonna flip it. Oh, it's 32, not 35.
Yeah, that's right. Okay. So this 5, are we listening? Is going to cancel this 5 and this 5. So those are going to come outside of my radicals. But this x cubed was a remainder that has to stay. So this becomes 2x times the 5th root of x cubed. So that remainder stays under the same radical we started with. No absolute value on that one because I had a 5th root, which is an odd root, so I don't have to worry about it.
But you don't have to put those things because
Because it was an odd root because I started with 5.
Can you even break that down even more?
no.
No, because you can't take the 5th root of something to the 3rd power. Like it wouldn't be a whole. So we could definitely do portions of x, but it wouldn't be fun.
Yes.
I mean,
Does everybody see what we did?
I thought math was fun, so.
Oh, it's fun to me. It's not fun to you.
Okay.
Big difference.
Not right.
Does everybody see what I did? So whatever doesn't come out evenly, we consider a remainder that has to remain under the radical. Are we all okay with that?
Yes.
Okay, so let's do one more, and I'm done with this, okay? So this is example R.
R.
That's fine.
You're pretty good at this.
Dang it. Correcto.
Correcto, I like that.
does not.
Wait,
Multiply to get
I
the
don't know
negative
how
27.
no.
Are you talking about like x to the 7? I'll show you.
I'll grab a stick.
Wait, there's a negative. It's not possible.
Ah, Brandon, say that louder.
Oh,
It's not
yes.
possible.
That is.
Can't do
No,
it.
it's not.
Hold
There's a
on.
negative.
I need everybody to stop talking and listen to what Brandon is saying.
But
Say
it's
say what you thought.
It's a negative. So I thought it was possible, but it was possible.
Okay, so he instinctively went to we can't do this because I have a negative whole number under there. That only applies if I'm taking an even radical. So because this is odd, it very well could have a negative whole number root. I still check for it the same way in my calculator. In parentheses, I would do negative 27. I would do the upward arrow caret to the parentheses 1 divided by 3 power. What answer do we get?
Negative.
We get negative 3. Then I take this into the 7 at this last low part, I promise. 7 is not a multiple of 3, but what is? Hold on, stop. 7 is not a multiple of 3, but what is?
4 plus 3.
6. So I need to break this down into the x to the 6 and x to the 7, and x to the 6 becomes x squared cubed, and then, sorry, and then I just have an x1 out there, because 6 plus 1 is 7. We will continue this on Monday. Have a wonderful day. Oh no, do your homework as much as you can. I'm so sorry. What? Oh, that's not good.